This video is about the area between two curves, but before we do that, let's go over a little review. So if we have some interval from a to b, then that area under the curve would be a to b f of x dx, because what we're doing is basically drawing a little rectangle, and that's dx, that's f of x, and our area is f of x dx, which now our integral can add up for all of them. But with two curves, what we're doing is you have to think about it a little different. So we still have that same basic idea. We have that function f of x. And so that right there would be the rectangle that we could then sum from start to finish. Like that. So from start to finish, and it would add up all of those. But what we're looking for is the area between them. So this right here, I'm going to get a little closer there. This right here would be the rectangle that we want. So the area between the curves will be taking that little rectangle and moving it through the entire thing. Well, how do you create that rectangle? Some of you probably already see it. Well, if you have some function g of x right here, then if you were to find the area of the red one and the area of the green one and then subtract them, you would find the area of the light gray. Now, even better than that is you can think, well, okay, well, my f of x is giving me the red, g of x is giving me the green. So if I were to subtract these immediately, that would give me blue. And that's what it is. So what it is top minus bottom dx. And I know you want to say f of x and g of x, but it really needs to be top and bottom because you want to make sure you're always subtracting the smaller from the larger. Otherwise, we're going to be getting negative areas. And we don't get that when we're finding the area between two curves, even if it's below in a negative region. So if you think about it this way, if this was 10 here, and let me write that in red, and then the green was 7, the blue would be 3, because 10 take away 7 is 3. So if it always has that same difference, then we can even think about it this way. If this right here, that same location in blue, right? So the f of x then would give us negative, I'm trying to find the red real quick, negative 5, so from here to here, right? And then the green, that would be even farther down, so that would be negative 8. And you can see their difference is still 3. And if you subtract top from bottom, you would get negative 5 minus negative 8. And with the change of signs there, you end up with 3. So it always needs to be top, take away bottom, no matter where they are, even if it's a little bit above. So right here, to find that blue, right there, the top one would be at 1, and the green would be at negative 2. And so we do that same thing, 1 minus negative 2. It still gives us 3. So as long as we maintain top take away bottom, it will always give us the area between the two. So this is our formula for it. So let's try one. So we're going to find the area between these two curves. So the first thing you want to do is draw that one rectangle in there that we're looking for. And then that way you can label it as top and the other one as bottom. So whichever function hits the bottom of the rectangle, that's the bottom. Whatever function hits the top, that's the top. It also allows us to label it what they are. So this width is along the x-axis, making that our thickness, our dx. Remember, we still need to have our width and our height. So instead of using f of x, what we're going to use is the letter y, which is the same thing. So now we can say y equals. This also tells us to make sure that each of our functions is in terms of y. So this says y equals perfect. That says y equals perfect. Now we just need to label each one correctly. So this is what we're talking about. You can see the rectangle there. And what we're doing is if you make that one rectangle, then the integral will take all of those rectangles and add them up all the way through. And as you can see, going through it, our top here is always the same function, and our bottom is always the same function. That's what we're looking for. So going from 0 to 2, same exact function. So you can see our top function is the line, and our bottom function is the parabola. Now, how do you find out where they intersect? Well, you can use a calculator if you want, or you can just set them equal to each other. So if we take x squared and set it equal to 2x, and then we solve this, we get x equals 0 and x equals 2. So we know that it's going to go from x equals 0 to x equals 2. And now we have everything we need for our integral, because it's going to be start to finish of our top function minus our bottom function, and then the width of our rectangle. Because remember, the height is being given by subtracting each of these together. So we subtract the top function and the bottom function, which gives us the height, but the width is still going to be dx. So our start then is from 0 to 2, and our top function is the linear equation. You can see that the line y is there. So on these, you're going to have to graph them to figure out which is higher. There is another way, but graphing is the best. So our top function is 2x. Our bottom function is x squared. And then now we can just plug this in our calculator, and it gives us our answer. We can also do it by hand as well. But I want to make sure that you are doing these correctly, so I'd prefer you use a calculator for now. So plugging in our calculator, we end up with 4/3. And that's it. That's all you're going to be doing. So quick review here. You have some rectangle that you're forming. You draw the rectangle. You write y equals because that's the y value this way. And that's the x value going this way. So we write dx. Then you can make sure that our equations solve for y, which it is, and solve for y, which it is. And then you can write the top one here, 2x. The bottom one here, x squared. And then we just go straight for the integral. So it's from 0 to 2 of top minus bottom. So the integral from 0 to 2 of top minus bottom, and you're done. They're nice and quick. So the next video we'll do some more examples and some more tricks.